Hello everyone, welcome to the St. Joseph College for Women Autonomous, Vishakhapatnam. Department of Mathematics welcomes you for the online course on real analysis. Module 3, Differentiation and Mean Value Theorem. I introduce myself as Venkat Lakshmi, Assistant Professor, Department of Mathematics, St. Joseph College for Women Autonomous, Vishakhapatnam. Now we discuss about the main important problems on Lagrange's theorem. Discuss the applicability of Lagrange's mean value theorem for the given function f of x is equal to x into x minus 1, x minus 2 on closed interval 0, 1 by 2. Solution: the given function f of x is equal to x into x minus 1, x minus 2 is equal to x cube minus 3x square plus 2x. Clearly, f is a polynomial of third degree. First one, f is a continuous on 0, 1 by 2. f is a derivable on 0, 1 by 2. By Lagrange's mean value theorem, there exists C belongs to open interval 0, 1 by 2 such that f dash C is equal to f of b minus f of a by b minus a, which means 3c square minus 6c plus 2 is equal to 3 by 8 minus 0 by 1 by 2 minus 0, that is equals to 3 by 4. 12c square minus 24c plus 8 is equals to 3, that implies 12c square minus 24c plus 5 is equals to 0. Now we are finding the c value. So clearly the above quadratic equation not getting the factors. So we are going to formula method to find the roots of the quadratic equation in terms of c. What are the roots? We are using the formula here minus b plus or minus root over b square minus 4ac by 2a. From we get c value, that is equals to 6 plus or minus root over 21 by 6. So e is equals to 6 minus, we have two roots here, 6 minus root 21 by 6 belongs to 0, 1 by 2, but 6 plus root 21 by 6 does not belongs to 0, 1 by 2. So clearly here Lagrange's mean value theorem not satisfied on the given polynomial function. Next problem on Lagrange's mean value theorem. The given problem. Using Lagrange's theorem show that x greater than log 1 plus x greater than x by 1 plus x if f of x is equal to log 1 plus x for all x greater than 0. Solution: given that the given logarithm function f of x is equal to log 1 plus x for all x greater than 0, depend on the interval 0, x. Clearly f is a continuous on closed interval 0, x and f is derivable on open interval 0, x. By Lagrange's mean value theorem, there exists c belongs to open interval 0, x such that f dash c is equals to f of x minus f of 0 by x minus 0. So clearly 1 by 1 plus c is equals to log 1 plus x minus 0 by x. 1 by 1 plus c is equals to log 1 plus x by x. Therefore, c belongs to open interval 0, x. That implies 0 less than c less than x. That implies 0 plus 1 less than 1 plus c less than 1 plus x. Clearly, 1 greater than 1 by 1 plus c greater than 1 by 1 plus x. 1 greater than log 1 plus x by x greater than 1 by 1 plus x. Clearly, x greater than log 1 plus x greater than x by 1 plus x. The next problem on Lagrange's mean value theorem. Prove that pi by 6 plus root 3 by 15 less than sin inverse 0.6 less than pi by 6 plus 1 by 8. Solution: the given function f of x is equals to sin inverse x for all x belongs to closed interval a comma b. Clearly, the trigonometric function is a continuous and differentiation on, which means clearly f is continuous on closed interval a comma b and derivable on open interval a comma b. By Lagrange's mean value theorem, there exists c belongs to open interval a comma b such that f dash c is equal to f of b minus f of a by b minus a. 1 by root over 1 minus c square is equals to sin inverse b minus sin inverse a by b minus a. Therefore, c belongs to open interval a comma b, that implies a less than c less than b. So, squaring on both sides, a square less than c square less than b square, then minus a square greater than minus c square greater than minus b square, means we are multiplying with minus, less than become a greater than, the sign will be changed. 1 minus a square greater than 1 minus c square greater than 1 minus b square. Continuous of the above problem, that implies root over 1 minus a square greater than root over 1 minus c square greater than root over 1 minus b square. 1 by root over 1 minus a square less than 1 by root over 1 minus c square less than 1 by root over 1 minus b square. That implies 1 by root over 1 minus a square less than sin inverse b minus sin inverse a by b minus a less than 1 by root over 1 minus b square. That implies b minus a by root over 1 minus a square less than sin inverse b minus sin inverse a less than b minus a by root over 1 minus b square. Put b is equals to 3 by 5 and a is equals to 1 by 2. Substitute in place of b 3 by 5 and in place of a 1 by 2. Then we get 3 by 5 minus 1 by 2 root over 1 minus a value is 1 by 2 whole square. Then we get 1 by 4 less than sin inverse b value is 3 by 5 minus sin inverse a value 1 by 2 less than 3 by 5 minus 1 by 2 root over 1 minus 9 by 25. That implies 5 by 6 plus root 3 by 15 less than sin inverse 0.6 less than 5 by 6 plus 1 by 8. This is satisfied Lagrange's mean value theorem. The problem is the next problem on Lagrange's mean value theorem. The given problem is find C of the Lagrange's mean theorem of f of x is equals to x minus 1, x minus 2, x minus 3 on closed interval 0, 4. So which means the given f of x is a third degree polynomial. Solution: f of x is equals to x minus 1, x minus 2, x minus 3, that is equals to x cube minus 6x square plus 11x minus 6. Clearly, f is a third degree polynomial. That implies f is a continuous and closed interval 0, 4 and clearly f is a derivable on open interval 0, 4. Now we have to prove that by Lagrange's mean value theorem there exists an element c belongs to open interval 0, 4 such that f dash c is equals to f of 4 minus f of 0 by 4 minus 0. So 3c square minus 12c plus 11 is equals to 6 minus of minus 6 by 4 minus 0. 3c square minus 12c plus 11 is equals to 3. The value is c, 3. That implies 3c square minus 12c plus 8 is equals to 0. Clearly, this is a quadratic equation in terms of c. c is equals to 12 plus or minus root over 12 square minus 4 into 3, 8 by 2 into 3. That implies 12 plus or minus root over 144 minus 96 by 6. That is equals to 12 plus or minus 4 root 3 by 6. That is equals to 2 plus or minus 2 by root 3 belongs to open interval 0, 4. Now, the most important theorem, that is Cauchy's mean value theorem. In the differentiation, there are three important main theorems. First one Rolle's theorem, second one Lagrange's mean value theorem, and third one Cauchy's mean value theorem. This is the third theorem in the differentiation. What is the theorem statement? If f is mapping from closed interval a comma b tends to R, then g is mapping from closed interval a comma b tends to R. R functions. Here we have two functions, that is f and g, such that f comma g are continuous on closed interval a comma b and f comma g are derivable on open interval a comma b. Third condition, g dash x not equals to 0 for all x belongs to open interval a comma b. Then there exists c belongs to open interval a comma b such that f dash c by g dash c is equals to f of b minus f of a by g of b minus g of a. Proof. Given that f is mapping from closed interval a comma b tends to R is g is mapping from closed interval a comma b tends to R are two functions such that f comma g are continuous on closed interval a comma b as well as f comma g are derivable on open interval a comma b. Third condition, g dash x not equals to 0 for all x belongs to open interval a comma b. Now we have to prove that there exists c belongs to open interval a comma b such that f dash c by g dash c. That implies f of b minus f of a by g of b minus g of a. Now we are defining one function, that is pi is mapping from closed interval a comma b tends to R. How can such that pi of x is equals to f of x plus a into g of x for all x belongs to open interval a comma b, a belongs to R. Here the constant function a is a constant to be determined such that pi of a is equals to pi of b. Now continues now Cauchy's mean value theorem. F of a plus a into g of a is equal to f of b plus a into g of b. A into g of a minus a into g of b is equals to f of b minus f of a. Then from this term and this term, a is a common, take outside, then we get g of a minus g of b is equals to f of b minus f of a. Then we have to find out a value. A is equals to f of b minus f of a by this g of a minus g of b transfer to RHS side. Then here we are multiplying this value, then taking to RHS side, the value is dividing, which means g of a minus g of b. So finally we got a value. Therefore f comma g are continuous on closed interval a comma b. That implies pi is continuous on closed interval a comma b. F comma g are derivable on open interval a comma b. That implies pi is derivable on open interval a comma b. Therefore pi satisfies all conditions of Rolle's theorem. There exists c belongs to a comma b such that pi dash c is equals to 0. F dash c plus a into g dash c is equals to 0. That implies f dash c is equals to minus a into g dash c. F dash c by g dash c is equals to minus a. So here what is a value? A value is f of b minus f of a by g of a minus g of b. That is equals to, we are multiplying with minus, then we get f of b minus f of a by g of minus g of b. Note point, if g dash x is equals to 0 for all x belongs to open interval a comma b, then f of b minus f of a to g dash c is equals to g of b minus g of a to f dash c. Now we discuss about the problems on Cauchy's mean value theorem. The problem is verify Cauchy's mean value theorem for f of x is equals to x square, g of x is equals to x cube in the closed interval 1 comma 2. Solution, here two functions are given. The two functions are algebraic functions, so that the given two functions f of x is equals to x square, g of x is equals to x cube. So now we are finding the derivative of f of x and derivative of g of x. So the derivative of f of x means f dash x is equals to the derivative of x square is 2x. Then the derivative of g of x is g dash x, that is equals to derivative of x cube is 3x square. Now here a value is 1 and the b value is 2. Clearly f comma g are continuous on closed interval 1 comma 2 and derivable on open interval 1 comma 2. By Cauchy mean value theorem, there exists an element c belongs to open interval a comma b such that f dash c by g dash c is equals to f of b minus f of a by g of b minus g of a. So that implies 2c minus 3c square, that is equals to 4 minus 1 by 8 minus 1. That implies 2 by 3c is equals to 3 by 7. That implies what is the c value? C is equals to 14 by 9, which belongs to open interval 1 comma 2. So here clearly Cauchy mean value theorem is verified on the given interval 1 comma 2. Now we discuss about the problems on Cauchy mean value theorem. The given problem is find C of Cauchy's mean value theorem for f of x is equals to root x, g of x is equals to 1 by root x in closed interval a comma b where 0 less than a less than b. Solution: given that f of x is equals to root x, g of x is equals to 1 by root x, f dash x, derivative of f of x means f dash x is equals to root x, derivative of root x 1 by 2 root x, derivative of g of x means g dash x is equals to minus 1 by 2 into x power 3 by 2. Clearly f comma g are continuous on closed interval a comma b and derivable on open interval a comma b. By Cauchy's mean value theorem, there exists an C belongs to open interval a comma b such that f dash c is by g dash c is equals to f of b minus f of a by g of b minus g of a. Now 1 by 2 into root c by minus 1 by 2 into c power 3 by 2, that is equals to root b minus root a by 1 by root b minus 1 by root a. That implies minus c is equals to root b minus root a into root b root a by root a minus root b. That implies minus c is equals to minus root b root a. That implies c is equals to root a b belongs to open interval a comma b. The next problem on Cauchy's mean value theorem. Find C of Cauchy's mean value theorem for the given two functions are f of x is equals to 1 by x square, g of x is equals to 1 by x on closed interval a comma b. A comma b is a positive integers, which means greater than 0. The given two functions f of x is equals to 1 by x square, g of x is equals to 1 by x. Now we are finding the derivative of f of x and g of x. The derivative of f of x is f dash x is equals to the derivative of 1 by x square is minus 2 by x cube. The derivative of g of x is g dash x is equals to the derivative of 1 by x is minus 1 by x square. Clearly f comma g are continuous on closed interval a comma b and derivable on open interval a comma b. By Cauchy's mean value theorem, there exists C belongs to open interval a comma b such that f dash c by g dash c is equals to f of b minus f of a by g of b minus g of a. Now we are substituting that minus 2 by c cube minus 2 by c cube by minus 1 by c minus 1 by c. This is a f of b value, this is a f of a value. This is a 1 by b square minus 1 by c square by 1 by b minus 1 by a. That implies 2. So here 1c and here 1c cancel, will get 2 by c. Will get 2 by C, that is equals to 1 by B plus 1 by A. That implies 2 by C is equals to A plus B by AB. That implies what is C value? C is equals to, we are cross multiplication. We do the cross multiplication, then we will get 2AB by A plus B. This belongs to open interval A comma B. The next problem is, if f is continuous on closed interval a comma b and derivable on open interval a comma b, then prove that there exists c belongs to open interval a comma b such that 2c into f of b minus f of a is equals to f dash c into b square minus a square. Solution: given that f is continuous on closed interval a comma b and derivable on open interval a comma b, consider G is mapping from closed interval a comma b tends to R by, how to define this G of x? That is equals to x square. G of x is equals to x square. Then what is the derivative of G of x? G dash x is equals to x square derivative is 2x, which is not is equals to 0 for all x belongs to open interval a comma b. Clearly f comma g are continuous on closed interval a comma b and derivable on open interval a comma b. By Cauchy's mean value theorem, there exists c belongs to open interval a comma b such that f dash c by g dash c is equals to f of b minus f of a by g of b minus g of a. So here f dash c by, what is g dash c? 2c. That is equals to f of b minus f of a by b square minus c square, which means g of b means x square. In place of x we are substituting b, which means we get b square minus c square a square. That implies 2c into f of b minus f of a. We are doing cross multiplication here. We get 2c into f of b minus f of a. That is equals to f dash c into b square minus a square. The problem is completed. Thank you.